Okay, so problem number 15 here was one that you just got doing on your graphing calculators where it said find all the real zeros. So how did you find the real zeros? You graphed it on your graphing calculator and you saw where this one crossed the x-axis, right? Okay, so you graphed this function on your graphing calculator and then you looked at the graph or you looked at your table, and where were the zeros located?
Negative 1, negative 2.
Negative 1 and negative 2?
Yep.
You guys remember this? Okay? Okay? So negative 1, 0, and negative 2, 0. If I really want to write them as coordinates, I'd write them this way, right? Okay? I'm fine with just making a list, all right? But truly as coordinates, that's what they are, okay? But no. Okay? Now, what is different about this one as opposed to some of the other ones that you had to do? There's only 2 zeros, but what's the highest power? 4. 4. So what does that mean?
2 of them aren't rational.
There must be 2 of them that are complex or imaginary, or in other words, they have an I in them, right? Because these are the only 2 real numbers where the graph crosses the x-axis. Okay? We're going to have to find all of them, though, now. This is where we're making the step up, okay? We can use our calculator to help us find the real ones. But they will not, the calculator will not help us find the imaginary ones, or the complex ones. All right? So, here's what we will have to do. Because you're going to get a problem like this where I say, not just find the real zeros, find all of the zeros. You guys see where I'm going to go with this? You see what you're going to be expected to do? Calculator's only going to give you a couple, you got to find the other ones. Now, here's a big concept. If negative 1 is a 0, and negative 2 is a 0, could we use those zeros to do synthetic division on this polynomial?
Yes.
Yes. Because we know if there's zeros, they're going to go into it evenly, right?
Yep.
If we do synthetic division twice, once with negative 1, and then take that answer and use negative 2, what power will we have left on our polynomial? X to the
Third.
second. Why second?
Because we use
X. Get rid of the X.
What are we starting with? X to the 4th. When I do the first division with one of these numbers, I'll be down to X to the 3rd. But then when I do another division with the other 0, then I'll be down to X to the 2nd. Once I have it down to X to the 2nd, do you guys have methods on how to solve?
Yes.
Absolutely. We spent a whole chapter on it. Okay? So that is the process that we're going to have to take right now to find those other zeros. We're going to have to see what zeros we can find on the graphing calculator. We found 2. That's good. Okay? But then we're going to do synthetic division twice to get us down to a quadratic. And then take that quadratic and find the zeros of that by setting it equal to 0 and solving. Okay? So, first thing I'm going to do, I'm going to do synthetic division by putting a negative 1 in the box right up here. And then I got 1, 7, 26, 44, 24. Will. Remember, this is the 0 of the function, okay? If this is the 0, what would the factor be? The factor would be x plus 1. What you're thinking, okay, I want to make sure it's very clear, okay? this polynomial here, because negative 1 is a 0, I know definitely that x plus 1 is a factor. I also know that x plus 2 is a factor. I don't know what that third one is yet, but I'll get to it after I do my divisions. So what you're thinking is, okay, well, back when we first started doing synthetic division, we put the opposite of something in the box, right? Well, remember, for those problems, I was giving you a factor. Like I said, hey, x plus 1 is a factor. Well, because x plus 1 is a factor, what number is actually the 0 of the function? Negative 1, and the 0 is what always goes in the box right here. Does that clarify? Okay. And Jake, if I get close to 15, you gotta let me know, okay?
Okay.
All right, synthetic division here. What do I do with the 1, Jake?
Bring it down.
Bring it down. What do I do with this one, Emma?
Multiply it by the negative.
Multiply it by the number in the box. 1 times negative 1 is how much? Negative 1. Zach, where do I put the negative 1?
Under the 7.
Right underneath the 7. Okay? Marshall, what do I do with the 7 and the negative 1?
Add them.
Add them and I get
6.
6. Okay? Katie, what do I do with the 6? Multiply by negative 1. Answer? Negative 6. Where I put the negative 6?
Under 26.
Under the 26. What do I do with those?
Adam.
Add them.
20.
Can I keep going faster now?
Yeah.
Okay? 20 times negative 1, negative 20. Add 24. Multiply.
0.
Negative 24. 0.
What if you don't?
If you don't get 0,
Yeah.
you screwed up. Okay? Because we know negative 1 is a 0. We saw it on our calculator screen. So it just means you made an error in your synthetic division somewhere. Okay? Or maybe you typed it in your graphing calculator wrong from the very beginning and negative 1 really isn't a 0 of the polynomial that was given to you. But assuming you did the graphing calculator portion correctly and you saw this graph cross the x-axis at negative 1, I guarantee you when you do synthetic, if you do it correctly, you will get 0 for your remainder back there. Darren.
I got this. It's really weird.
Okay, hold on. Yep. All right.
You can't do it.
Yeah, you're not going to be able to factor it. I guarantee you because they're not going to be real.
Yeah, well, they're both pluses.
Okay? Okay so far?
Done.
We've only done it once. Keep in mind now, this would be 1x cubed plus 6x squared plus 20x plus 24. Let's do it again now, but this time we're going to use negative 2 in the box with these new numbers. We are going to use these new numbers now, okay? So negative 2 is going to go in the box, and then we're going to use these numbers here. I'm going to write them again just so you can... One, negative 2, 4, negative 8, 12, negative 24, 0. So that gives me 1x squared plus 4x plus 12.
Can't do it.
Right?
Special times. Right?
That would be as far as you could factor it, correct? Yes. Okay? Absolutely, and solve it. Mm-hmm.
Oh, okay.
Yep, that's what you're going to do. You're going to set equals 0 and solve it. But you can't do it by factoring, is the only thing. Okay? Speak up. What questions do we have so far?
I can do it, dude.
Nothing? I'm doing a wonderful job of teaching.
Yeah.
Can I explain it differently to anybody? Isaac.
Does it matter which 0 you do first? Somebody negative 241.
Okay? Do you guys think it matters?
No.
Why do you think it doesn't matter?
I feel like it's going to count the same anyway.
Your first step might not be the same, but at the end here, it's just like numbers, okay? If I take 20 and I divide by 2 and then I divide by 5, would I get a different answer if I took 20 divided by 5 divided by 2? you get the same place eventually, right? So whether you divide by this one first or this one first, I guarantee you, as long as you do both of them, you will get to this answer. Good question. Okay, anybody else? Everybody good so far?
That's my time. You got 10.
10? Okay. All right, so now this polynomial right here, if I asked you to factor it, this is as far as you could factor it, this right up here. X plus 1, x plus 2, and then whatever was left over after we did our division. This is not factorable any further, which makes sense. Because if this was factorable further, don't you think we would have seen all 4 zeros? Seen all 4 zeros on the graphing calculator? If they were all real, we would have seen them all, and this would have been nice to factor, and we'd get a couple nice little factors, and we'd see all the zeros pretty easily. This is not factorable, but can we still set it equal to 0 and solve for x? Can we still find the zeros? Absolutely. I'm just guessing the answers are going to be imaginary. Okay? Questions? Anything? So, we know -1 is a 0. We know -2 is a 0. We just don't know what these zeros are. So let's set that equal to 0. X squared plus 4x plus 12 equals 0. How do you want to solve it? Completing the square, or you guys love completing the square, that's odd. Quadratic formula. Either one will be fine.
I like them.
Okay? Complete the square, use the quadratic formula. I'm kind of a quadratic formula person. Okay? So here I go. Negative b plus or minus square root b squared minus 4 times 1 times c all over 2a. 2 times 1 is 2. Negative 4 plus or minus the square root. 16 minus 48 would give me a negative 32 all over 2. Simplify the square root of negative 32.
4i.
4i root 2. And then, are both terms divisible by 2?
Yep.
So negative 2 plus or minus 2i root 2. There are my other 2 zeros.
This is my handwriting. My handwriting isn't this. I do this.
So there was a 0, there was a 0. I found those two on the graphing calculator. Negative 2 plus 2i root 2 is the third 0. Negative 2 minus 2i root 2, there's the fourth 0. Now I have all of them. Go ahead and pause it.